Assalamu alaikum friends. My name is Faisal and today we are going to catalyze the remaining numericals of the chapter 6, and the name of the chapter is Mechanical Properties of Matter. So without wasting any time, I'm going to read the next statement of the next numerical, which is the numerical 6.3. And the statement is, an examiner asked that when a solid of mass 60 gram is lowered into a measuring cylinder, the level of water rises from 40 centimeter cube to 44 centimeter cube. Here's a twist. And what is that particular twist? That the level of meniscus. Here, the meniscus is formed due to water, and you know that due to water, the concave meniscus is formed on the surface of measuring cylinder. And the level of concave meniscus rises from the reading 40 centimeter cube to 44 centimeter cube. So, you know, in measuring cylinder is a volume measuring instrument. So it is a measuring instrument to measure the magnitude of a physical quantity, which is the volume of the object. So to quantify the volume of the object, we have to dip a particular object into the measuring cylinder, and the level of meniscus rises from an initial reading to the final reading. And the volume of the object is actually the change or the incremental factor from the initial reading to the final reading or the achieved reading. So that change, that incremental factor, that increasing factor is considered as the volume of the object. So here the initial reading here the initial reading of the volume before the immersion. Before we did immerse the object, the volume, the initial reading of the volume or the initial reading of the concave meniscus of water is approximately, is denoted by the symbol initial volume, is approximately 40 centimeter cube. And you know, centimeter cube is not the unit of volume in SI system. So to convert centimeter cube into meter cube, we have to substitute the value of prefix, which is centimeter cube. Centi actually. So I have written a shortcut here to convert centimeter cube into meter cube, and that particular shortcut is actually pertained as 1 centimeter cube as a standard reference is equivalent to 10 to the power -6 meter cube. So here when we put or replace the centimeter cube, the 40 centimeter cube is converted into meter cube, and its value is approximately 0.0004 meter cube, which is written as when because I'm using Excel, and you guys will use the paper for the sake of solving these critical problems. And on the paper, the standard scientific form of this particular figure is actually written as 4. When we shift decimal point up to 5 digits on the right hand side, then the value will become 4 multiplied by 10 to the power -5 meter cube. And the same here, final reading of the measuring cylinder of the immersion of the object, complete immersion here, and that is final volume of the whole apparatus, which is 44 centimeter cube after the immersion of the object. Now that particular reading 44 centimeter cube is actually the inclusive factor. Inclusive factor means it includes the volume of the water, which is into the measuring cylinder, which is into the cylinder of the measuring cylinder, and the volume of the object. So to separate the factor of volume of the object, we have to subtract that value. We have to subtract 40 centimeter cube, which is the initial value, from that value, which is the final figure, which is the final volume after the immersion of the object. So that volume, when we write that particular figure into meter cube, the centimeter cube in meter cube will be expressed as 0.000044 meter cube, which in standard scientific form can be written as 4.4 multiplied by 10 to the power -5 meter cube, and the standard reference here 1 centimeter cube is equal to 10 to the power -6 meter cube. What we did here to convert centimeter cube into meter cube, we just replaced the value of centimeter cube, which is 1 centimeter cube is equal to 10 to the power -6 meter cube. So mass, what is the mass of the solid object? The mass of the solid object, which is denoted by the symbol small m, that is 60 grams. So to convert 60 grams into kilograms, because kilogram is the SI unit, is a unit of mass in SI system. So standard reference here, 1 kilogram is equivalent to 1000 gram. So to convert gram into kilogram, we have to divide the respective figure, the respective value, with the factor of 1000. And why with the factor of 1000? I have summarized multiple times in the classroom that whenever we have to convert gram into kilogram, we have to divide with the factor of 1000. And why is it so? we have discussed logically in our classroom. So we have to calculate the density of the solid object. So to attribute the density of the solid object, firstly, we will determine the volume of the object. And as I have discussed, in Meiring cylinder, the change in the level of meniscus anticipates the unknown volume of the object. So the change is equivalent to final value, or final volume of the Meiring cylinder after the immersion of the object minus initial volume before the immersion of the object. And after subtracting these two figures, I'll get 4 multiplied by 10 raised to power approximately, because I'm pronouncing in standard scientific form, and that is 4 multiplied by 10 raised to power minus 6 meter cube. So using mathematical relationship, which is density of an object is equal to mass divided by volume, or total mass possessed by the object, or the total quantity of matter possessed by the object divided by the internal spacing, or the internal spacing of the object, which is called as volume of the object. So after putting values, these are density is equivalent to 0.06 divided by that particular value, which is 4 multiplied by 10 to the power minus 6 meter cube. I'll get a value that is I'll get the value which is mass. The value of mass is 0.06. The value of mass is 0.06 divided by the volume of the object, and the volume of the object is calculated as 4 multiplied by 10 to the power minus 6 meter cube. And finally, the volume, the mass of density of an object is calculated as 15,000 kilogram per meter cube, and in standard scientific form, it is expressed as 1.5 multiplied by 10 to the power 4 meter cube kilogram per meter cube. And why? Because standard scientific form highlights that we have to express a particular value in such a way that the power of 10 is multiplied with the number which lies between the domain between the range of 1 and 10. So to convert 15,000 into standard scientific form, we have to move the decimal point from the very right hand side towards the left hand side up to 4 decimal places. So after displacing that decimal point up to 4 decimal places, the 15,000 kilogram per meter cube is expressed as 1.5 multiplied by 10 to the power plus 4, because whenever we shift the decimal point towards left, the power of 10 is expressed in positive numbers. So now I'm going to read the statement of the numerical, which is numerical 6.3. 6.4, sorry, actually it is the numerical 6.4. It is very easy peasy. It is very, you can say that one of the most easiest numericals of the chapter 6. It can be asked. It can be asked as a short question, as a summarized question in your exam. So here, a block of density 8 multiplied by 10 to the power 3. 8 multiplied by 10 to the power 3 means whenever we convert 8 multiplied by 10 to the power plus 3, at 10 to the power plus 3 means 3 zeros after 1. So 3 zeros after 1 means 3 zeros after 1 means 1000. So whenever we multiply 8 with the factor of 1000, it will be converted into 8000. So the density of the block is denoted by the Greek letter, which is rho, and it is equivalent to 8000 kilogram per meter cube. So volume of the object is given by the examiner, that is 60 centimeter cube. So to convert centimeter cube into meter cube, we have to put, according to the standard reference, the value of 1 centimeter cube, which is 10 raised to the power minus 6 meter cube. So 60 centimeter cube is expressed in kilogram per meter cube as 6 multiplied by 10 raised to the power minus 6 meter cube. 10 raised to the power minus 5, sorry. Actually, it is 10 raised to the power minus 5 kilogram per meter cube. Kilogram per meter cube, sorry. It is cubic meter, sorry. It is meter cube or cubic meter, because volume is expressed in meter cube or cubic meter. Cubic meter is the SI unit of volume. So to calculate mass of the block, which is denoted by the symbol small m, we use the mathematical relationship, which is density is equal to mass divided by volume, where mass is equal to density times volume. And by putting the values of density and volume of the object, we'll get the figure, which is mass of the object multiplied by volume of the object, and the figure is 0.48 kilogram, which is the total magnitude of the quantity of matter of that particular block about which the examiner is asking to calculate the mass. So here we have discussed the two numericals, which are 6.3 and 6.4. If you have any query, you can ask or you can contact me without any hesitation. Jazakallah khair.